We're going to talk briefly about how to draw Lewis dot structures. So the first thing we're going to do in the first example is we're going to count the number of valence electrons around each atom. And so carbon in group 4 of the periodic table has 4 valence electrons. Then hydrogen, there are 4 hydrogens, each of them with 1 valence electron, for a total of 4 valence electrons. So the overall molecule has 4 from the carbon, 4 from the hydrogens, so for a total of 8 valence Now that we've determined how many valence electrons each atom has in the overall molecule, we're going to go ahead and start drawing a proposed structure. And so what we're going to do is we're going to place heteroatoms and carbons on the inside. And so I'll put carbon there, and I'll put its valence electrons around it. So it has 4 valence electrons, so I drew 4 valence electrons around it. And so next, we're going to put the hydrogens on the outside and draw their valence electrons. So every molecule has achieved its desired bonding pattern. And so let's take a look and check whether everything has an octet or duet that it wants. So does carbon have the octet? We have 2, 4, 6, 8, 2 electrons in each bond. So it did achieve its octet. Now let's look at hydrogen. Hydrogen has 2 electrons in that bond on it. And then, so the hydrogen here wants a duet. And so did these hydrogens achieve their duet? Yes. So each hydrogen has a bond, and each bond contains 2 electrons. So the hydrogens achieved their duet. And so we'll move on to the next example, and we'll look. And so hydrogen has 1 electron. There are 2 of them for a total of 2 valence electrons. And then oxygen has 6 valence electrons. And so the molecule overall has 8 valence electrons. And so in the last example, we didn't really make use of the fact that there were 8 valence electrons total in the molecule. But as we deal with more complicated, larger molecules, we'll actually need that information. So I've included it in the steps of determining the Lewis dot structures. And so the next thing we do, we put heteroatoms and carbons on the inside. And so oxygen gets to be put on the inside, and it has 6 valence electrons. So we're going to draw 1, 2, 3, 4, 5, 6. Again, oxygen is in group 6 of the periodic table, and so that's why it has the 6 electrons. And so hydrogen we're going to place on the outside. And so we have 2 hydrogen, put them each on the outside. Now this is our proposed structure. I'm going to check if each structure is satisfied. So does the oxygen have its octet? So we have 2, 4, 6, 8. Yeah, it does. And so there is that. And then next we're going to have hydrogen. Does hydrogen have its duet? Both of them do. So hydrogen 1 has a bond, and there are 2 electrons in that bond, so it's good on its duet. And so hydrogen 1 has 2 electrons contained in that bond, so it's also good on that duet. And so both of them have achieved the octet and duet, so this is the correct Lewis structure. Now, a molecule can have multiple Lewis structures as it gets larger, but when we're dealing with smaller molecules, typically there's only one correct Lewis structure. Now, I like to make rules that we can follow on each problem regardless of the specific situation. And so the first step of determining the first step in drawing Lewis structure is to determine how many valence electrons are in each atom and in the overall structure. So we'll take nitrogen as an example to follow these steps. So nitrogen, we have 5 valence electrons because it's in group 5 of the periodic table, and we have 1 valence electron, and there are 3 hydrogens for a total of 3. So the molecule, so let me write that, valence electron. So the molecule overall has 8 valence electrons. Again, we won't make use of the 8 valence electrons total in this situation, but in further examples, which we'll talk about later, we'll need that information. It will be helpful. And so in this case, again, we're going to put the heteroatoms, atoms that are not carbon and hydrogen, on the inside. We're also going to put carbon on the inside as well when we have it, but in this case we only have nitrogen, so we're going to put its 5 valence electrons around it. So we have the 5 valence electrons, and then we have the hydrogens we're going to put on the outside, each with their valence electrons. And so this is the proposed structure, and now the next step would be to place heteroatoms on carbons on the inside, which we've done. So nitrogen's on the inside, hydrogens, we're going to put them on the outside, which we've done. Step 3 is to determine if each atom meets the octet rule. And so nitrogen, did it get an octet? Well, let's count. 2, 4, 6, 8. It did. So we are set with the nitrogen. It's happy because it's got that octet rule. And so the next thing that we need to look at, do the hydrogens have their duet? And they do. Each one has 2 electrons contained in the bond that it is connected to with nitrogen. And so they all achieve their duet. So this is the correct structure, Lewis dot structure, for NH3. The final step is to determine the formal charge. And so we're going to use that formal charge equation, which we'll go over in another lesson, to be the final step of determining what the Lewis dot structure is. But as of now, these are the steps to determine Lewis dot structure, and we follow them on every molecular formula.